Hello and welcome to today's session. My name is Matt Bichelle, Director of Product Marketing here at Aerospike, and it is my pleasure to serve as today's moderator for Aerospike Management APIs and Operations at Scale. In order to learn how to leverage and address operations at scale, PayPal performs OS patching and DB software upgrades for all of its clusters spanning over 1,800 servers every few months. We'll also learn about how they rotate security certificates across the fleet with zero issues and how they're managing availability across clusters with failovers. But before I introduce today's speakers, you can download this session slides by accessing that cloud icon on the left. Also, to make the session more interactive, we encourage you to enter your questions in the Q&A box where we will be fielding them at the end. And now to introduce our presenters. Neha is a member of technical staff at PayPal, where she is currently involved in building automation and monitoring solutions for NoSQL systems. At PayPal, she is working on administrating 150 plus complex architecture services and leads the team to maintain their availability. Deepti Sharma is Database Engineer 3 at PayPal, supporting NoSQL databases, and is responsible for automation of PayPal's Aerospike platform. Prior to PayPal, Deepti worked on Oracle databases and content management systems at Vignette. And Vincent Chong, MTS2 Database Engineering PayPal. He's over 20 years experience in the industry, having been with PayPal for 8. He's currently responsible for software development and implementation of PayPal's real-time big memory data platform, as well as designing and developing its failover solutions. He's also responsible for automation and operational management of PayPal's Aerospike NoSQL platform, and serves as its data architect for onboarding use cases onto it. And with that, Vincent, please take it away.
Okay, thank you, Matt. Thank you for the introduction. Hi, everybody. My name is Vincent Chong. So today in this session, we are going to share with you the growth journey of Aerospike at PayPal, how we achieve operation and monitoring at scale. So today we have 3 sections. Number 1 is the growth journey. Number 2 is the automation framework that we use. Number 3 will be how we monitor so many hosts at the same time. So about growth journey. So today at PayPal in year 2020, we have about 2,000 servers comprising 60 racks, 106 clusters, and there are about more than 10 application teams using the platform. So altogether, there are actually more than 10,000 client applications, client hosts connecting to our platform. So that's an enormous footprint. And also, this platform is supporting about 500 developers for their daily work. So in terms of use case, the usage of Aerospike at PayPal has many of them. To name a few, the number 1 application we use is for fraud detection, as you know, our business. And number 2 is to check the compliance rules and regulations. Number 3 is that we also use Aerospike as a platform to build some kind of graph relationships. And then we also use it for our mobile device fingerprints. For example, when people log in using your mobile phone or Internet of Things, we would track their MAC address and IP and all that kind of information for our purpose. And then we also have event histories where we see how often the user log in and what did he do in the last 1 month and so on and so forth. Now, in terms of deployment architecture, the reason why we have 2,000 servers is because we have to make sure our production traffics are up all the time. We have a 5.9 uptime requirements. So typically, our clusters consist of 3 clusters in a group. One is primary, which is serving the primary traffic. Second one would be the standby in case the primary has problem. The third one would be for disaster recovery in the event of entire data center going down, such as in an earthquake. And typically, we maintain a replication factor of 2. And also, we chose to build a cluster of 20 nodes for various reasons. Basically, it's based on our need for data capacity and also our experience in terms of how often a hardware problem happens. And typically, in a 20 node clusters, The physical storage will be about 128 terabyte, and we use SSD. So this is a diagram illustrating the fact that we have 3 clusters in a group. So left-hand side is a primary in blue color. The right-hand side is the red color, which is our standby in case the blue color goes down. And then at the same time, there is another blue color in another data center labeled as a data center 2. And at any given time, the majority of our traffic is routed to the first blue color on the left. And then we maintain a small percentage of traffic to the blue color on the bottom, so that we are certain that the disaster recovery cluster is actually serving live traffic, ready to pick up 100% of the traffic in the event of a disaster. So that's the background of our deployment architecture. So going to our growth journey, in year 2016, we actually only has about 120 hosts and comprising 2 cluster groups. So that would be 6 cluster all in total. As you can see, the growth rate is actually very steep. So in 1 year, we grow from 120 to 900. And then in the 3rd year, we grow to 1,200, all the way to 2,000 in today. That's a very steep growth curve. So how do we do that, right? The answer is automation. In the beginning, when we have only 120 servers, everything is done manually, naturally speaking. So we were doing things in a rather primitive way. We were relying on a tool called CSS-HX to simultaneously log into 20 nodes and push commands and perform maintenance tasks. Needless to say, that is actually not going to scale. So in 2017, we started to, a project to automate all the mundane tasks by using Ansible script. So we have a POC project started in 2017. As you can see on the graph, which is the yellow color, without the automation, right, it would be pretty much a linear effort in terms of however many hosts you need to maintain, that's how much time you have to spend in maintaining it. So that would be a nightmare for scaling to thousands of hosts. So in 2018, we started to see some fruit in our investment in automation. So as you can see on the left side, with the automation, right, there is an initial hum in terms of effort because we have to develop the Ansible scripts. And however, that's an investment. So in the second half of the year, we start to reap the reward of our investment in our time, because as you can see, the amount of manual power start to go down to about 0.5 manpower for any particular given task, such as upgrading the OS or patching any bug fixes. So this is the graph I was talking about. 2019, we developed more automation scripts, so therefore the amount of effort is less, but at the same time we have 1,800 servers, right? So our team size has grown from 2 to 4 people. In that year, we were able to patch 1,900 hosts, and we were able to perform 1 cycle of software upgrade of Aerospike, and also at the same time, in the same year, we were able to patch the OS to all 1,800 servers. To us, that was a pretty big accomplishment in the sense that we were able to leverage our automation scripts. The one thing that time, the reason why we can only perform 1 cycle was because when we bring down a node, it would trigger data rebalancing, right? And with the amount of data we have, typically 1 node would take 3 hours. So you can imagine 20 nodes will take about 60 hours. And then we have about 2,000 hosts. So you can imagine it would take about a whole year to finish the whole thing. Now, in year 2020, we start to really fully reap the reward of our investment in automation. As you can see, there are many peaks on the left. That's because we can simultaneously perform a lot of mundane operational tasks by the Ansible script that we developed. So in the same year, we were able to do TLS certificate rotation, OS patching, building new clusters, as well as software upgrades. So each one of them will take about weeks to finish for a cluster of 20 in a group, which would be like 60 servers, right? So this is a enormous accomplishment because we were able to maintain the same team size of 4 people, and at the same time also triage production problems. So how did we do that automation? I would let my colleague Dipti to go into a little bit of the detail for how we accomplished the automation by using Ansible script. Okay, Dipti, take your turn. Hello, Dipti?
Yeah, thank you, Vincent. Am I loud and clear?
Yes.
Okay. So, hello everyone. So, as Vincent covered in the previous slides, how our Aerospike inventory took a leap from a server count of 120 servers to a count of 2,000 servers. And we have been able to maintain our team size to 4. So, how did we manage that? I will cover in my next few slides that how automation had made it possible for us. So, is the screen refreshing? Can you see the next slide? I'm not sure that it gets pushed.
Yes, it looks good. Yeah, DP, it looks like it's refreshing fine.
Okay, so is it on the next slide? Because to me, it's not showing the other slide. Yeah, I think now it's there. Okay. So the core to our automation has been Ansible engine. We have automated all our daily operations by writing Ansible playbooks. That has helped us to manage our big Aerospike inventory. So be it creation of new clusters or adding more nodes to the existing clusters, truncating data sets, upgrading the databases in rolling fashion, or applying OS patches. So these are some of the example of playbooks that we have created. And this is just not the only ones. We have a long list. I've listed down just a few here to give an idea what kind of playbooks we have built. And now I hope you all know what playbooks are, but let me quickly give an overview of it. Playbooks are actually files where Ansible code is written in YAML format. YAML is yet another markup language, and they're like to-do list for Ansible, and they contain a list of tasks. So what we have done, we have segregated these tasks into logical groupings that we call as roles. And you can think of roles as small functionalities which can be used within multiple playbooks. So if we take an example of OS patching, we can break down into 4 or 5 steps, right? Like stopping and executing the OS patching scripts. Then we may have to reboot the machine and start the Aerospike services. And in the end, we may want to validate the node health or the cluster health. So we created roles for these logical steps, which in turn call Ansible modules. So these playbooks, roles, and tasks are very tightly integrated together. And to support our environment, we have written close to 50 playbooks and 78 roles. Now, a playbook can call multiple roles, and the same roles can be called by multiple playbooks as well. And that is the beauty of automation here. So if you see in this slide, the roles Aerostop and Aerostart, these are an example that these roles can be used by multiple playbooks, whether it's OS patching or DB upgrade. So the same roles will be called again and again. We don't have to rewrite them. Let me explain it in my next slide with an example. So in this slide, you can see some of the playbooks listed on the left-hand side. Again, if we start with add node, so as the name implies, this add node.yml playbook will be used to add a node to an existing cluster. And correspondingly, if you see somewhere in the middle, we have a remove node playbook as well to remove the node in case it has gone bad or we plan to decommission it. And we have also have playbooks for backing up the clusters or restoring. Then there will be for the OS patching. So OS patching, again, there are two kinds of playbooks, patching a single node, or we can do patching for the whole cluster in a rolling fashion. Then we also have DB upgrade playbooks for upgrading in a rolling fashion again. So these are some of the examples that we have for the playbooks. And to explain the relationship between the playbooks, roles, and tasks, you can see I picked up one playbook here, that is prepare new node. And this prepare new node, again, if we think of creation of new node, we will come up with some logical steps that needs to be executed as part of preparing this new node. So the first step would be preparing the OS, which will include creation of the Aerospike users or the Aerospike directories. And then we'll work on installing the Aerospike binaries. After that, we'll have some system level configurations for maybe log rotate. We'll have some cron job setup, and then for some changes for the systemd or the AS tools. And we'll be generating the config file for the Aerospike, and then we'll be changing some ownerships and starting the Aerospike services. And if required, we may have a role to create application specific users also. So now I'll pick up a role, generate config file here to explain how the tasks inside a role look like. And for this, I picked generate config file because I feel this is one of the most important roles, as Aerospike installation, upgrades, everything is dependent on how our config file is looking like. So on the right-hand side in the black box, there is a snippet in which you can see there are two steps defined. The first task is to back up the config file, and the second task is to generate a new config file. So now you may be wondering that we are preparing a new node. What does the first step mean? That we have specified backing up a configuration file, because for a new node, we don't expect a configuration file to exist. So this is because we are using the same role in database software upgrade as well. And in that case, we need to have a copy of the existing Aerospike file in case a rollback is required. So in that case, we will take a copy, we will back up this file, and then come to the next step of generating the Aerospike config file. Now, in this case, this step for taking the backup will be skipped. We will just directly jump onto the generation of the new configuration file. Now, this generation of config file is a little tricky and a little bit of challenging in terms of how do we generate a dynamic file, because all clusters come with varied needs. Say, for example, some clusters may want to have XDR enabled, and some clusters we want to have it enabled. And similarly, in some clusters, we may want to have a replication factor of 3, whereas in others, the replication factor of 1 may suffice. So depending on the criticality of the servers. So the challenge here was to create a consistent file in which we don't have to do any manual tweaking once created. So in my next slide, I will show you how we achieved it using Jinja 2 templates to generate the dynamic configuration files. Is this slide visible? I'm still doubtful because I don't see it in the preview.
It's still loading.
Okay.
There it goes.
Okay, thank you. Yeah. Explain what template is for us. So in Ansible, it's a file which will contain all our configuration parameters, and the dynamic values will be given as variables. So during the playbook execution, and depending on the conditions like which cluster we are using, the variables will be replaced with those relevant values. And we have made use of similar concept. We have created multiple templates to generate different sections of the configuration file. So we have a wrapper template file on the top, which further calls in other sub-templates to generate various sections of the file. Say, for example, the wrapper template will just create the basic structure of the Aerospike config file, and then the sub-templates will generate the sections as in XDR, metadata namespace, one for maybe storage namespace, and another one for logging. So in this slide, I've picked up an example of the XDR template to explain how our framework works. On the left-hand side, you can see there is a file, host file, showing only XDR-related parameters. And this host file serves as an input to XDR Ginger template. So that the template is given in the black snippet, in the black box, you can see. So this template will read the value, enable XDR is true, and we have provided a condition there which gets checked that if enable XDR is true, then only generate the XDR section of the Aerospike config file. So when this condition passes, the Aerospike config file section for the XDR will look like something in the gray box down below. And when we are specifying enable XDR is true, we have to make sure that we are also specifying other related parameters for the remote data centers and the nodes where we want to enable the XDR. So this is how we have tried to keep it as generic as possible for us. Now, in the next slide, I'll cover how we simplified the usage of configuration through the WAR files. So in this slide, on the right-hand side, you can see we have listed some variables. So these are 16 in total, and we just require these 16 variables to create a new cluster or a node. We just need to pass the values of these variables and we will be done. So let me pick one example for variable build. So because that's the easiest to understand and it's very simple to understand. So where build here has two files listed. So one will be for the Aerospike version 4.5 and another will be 4.8. So these files will have paths for different Aerospike binaries needed for installation. And we just need to pass the version in the host config file, which then gets installed by running the playbook. For all newer releases, the only step left for us will be to create a new version specific variable file and specify the path of the new. So that's how we have kept it so simple. And this slide only shows the essential configuration parameters that are required to create a cluster, but these are just not the configuration that are available. We have much more to it. So if you just want to run down quickly on the variables that we have TLS profile flavor, which actually specifies whether we want to have the storage pattern as block or file system. And then we have region depending on our data centers, the build, config, and then user profile. So we can also specify in the flavor that we want, whether our environment is GCP specific or means cloud or it's on-prem. So those kind of information we pass in these config files. Accordingly, our environment gets set up. So in the next slide, I'll cover the additional features that are part of the framework that we are supporting. So this slide is for the features that our framework is capable of supporting. So all the features here listed have a min, max, and default value. And if we don't specify any value, so the default will get spec'd up. So based on our needs, we can configure one namespace, and at the max, we can go to 4 namespace. But by default, it will only be 1. And similarly, for the XDR, we can set up up to 3 remote data center configurations. By default, we are not enabling the XDR. And similarly, for replication factor, we have a min of 1 and 3. But TLS will be enabled by default for whether it's intra-cluster or XDR. We have enabled TLS for all the clusters here. So storage type also we can specify whether we want to pick a file or block. So we keep on integrating new features from Aerospike in our environment. But at the same time, we have tried to keep our automation framework very generic in nature, that anybody can use it. It's in any environment, cloud or on-prem, as I already said. So if anybody is interested to know more about the framework or want to make use of it, we have a poll that will follow after this session, and then you can leave your name, email IDs, and we can get in touch with you. We can also open source it if there is interest, so please cast your votes there. Okay. Now, despite of so many complex processing in the background, we have kept our interface very simple. So as shown in the next slide, if you see in this slide, we are not passing any variable in the command line, and that is done to avoid any operational incidents or mistakes. All the configurations go into the cluster-specific host file, and only that is required to run any of the playbooks. So in my last slide, I will just summarize what we have accomplished using this automation. Sorry, I just... So using this automation, we have been able to patch all our Aerospike inventory of close to 2,000 servers in less than 3 months to meet our security and compliance needs. And being a financial domain company, we can't miss any of the server because we are obliged to fix all the vulnerabilities on our servers. So if we think of that the process was not automated, so we doubt that we would have been complete like we have achieved our target within the 3 months time. So we are doing it regularly every 3 months, every quarter. And along with that, it's not only OS patching, we are also having a cycle of DB upgrades each year to keep our environment up to date. And that doesn't involve much of human intervention for doing any of the monitoring, because monitoring also is very well automated, that Neha will be covering in the next part of the session. We just have to do a single click for the patching versus server by server patching that requires manual effort. We can do 24/7 patching, so we don't have to babysit the patching. We just can either schedule a job or trigger it, and it will be triggered in a rolling fashion, and multiple nodes will be done like overnight. So yes, of course, there will be errors that we have to come back and look and resolve at some point in time, but most of it is very smooth and goes well. So this has increased, help us increase the team efficiency and productivity. So now we can focus on other important value additional tasks. But had it been manual, we would have taken more than 6 months, of course. And even if we would have planned and executed in 6 months, that would have been with a bigger team size and much more effort. So you can see how we have achieved so much with automation and still being able to do with a smaller team size. Now, in the next part, Neha will be covering how our monitoring and reporting is automated. So, Neha.
Thanks, Deepti, for sharing automation using Ansible APIs. Hello everyone, this is Neha Runwal. I'll be sharing details on how we manage monitoring at such a large scale of 2,000 Aerospike hosts with only 4 team members here at PayPal. So why do we need monitoring anyway? Well, if you have Aerospike and you have users who come to you asking these questions, say, why do we see timeouts? And why there are failures while writing the data? And say, data is not getting replicated across the clusters. And which one is the biggest set, or what is the total set storage in a cluster? So if you have faced these questions and you had to triage manually, then you know why we need monitoring. So in our case, we have a large fleet of hosts and clusters. So with 500 plus users, we delegate these questions. And when it comes to find answers, we want to reduce the turnaround time and solve it as soon as possible. So to avoid manual triaging as much as possible, we have developed a monitoring tool named Manticore. It helps to perform automated failover to peer clusters if nodes are down in a primary cluster. It periodically informs us about the availability. It also helps fetching important metrics such as latencies, client connections, rebalancing, migrations, etc. So how does monitoring work? How does Manticore works? So it has three parts to it. First one is agent, second is dashboard, and the last one is reporter. So with 106 clusters, we run agents per cluster. Manticore agents helps in initializing the XDR reader and writer, which in turn helps us to find out latencies from client side. It also checks for the availability of the nodes in a cluster and if required, performs failover to peer clusters. So when dashboard really requests the data, the agent connects to the nodes in a cluster and runs different sinfo queries to fetch all the related stats. Manticore dashboard helps to put all these stats, which are written from the sinfo query, say in key value pair, in a more human readable format using HTML and CSS. So agents actually have REST APIs, which are indeed called by dashboard. And dashboard has its own REST APIs, which are called by reporters to really create that HTML view in email and send it to the users. So we don't have to do the basic tasks such as how many client connections are occurring and what is the latency between the clusters and what are the storage stats. This is all automated using Manticore. So how do we really achieve all this with just one application? So as you can see in the picture, we have like different Manticore agents which are installed per cluster. And then there is a heart of the Manticore which does all the customization on top of the data that is received from the agents and push it to the dashboard with all the information in a user-friendly manner. So it also feeds the information to the alerting system as well as to the graphing dashboard, Grafana. As you can see, the agents are horizontally distributed. So this Manticore is horizontally scalable and can be deployed in multiple hosts to avoid any issues. Say, if one agent goes down, it does not really affect the rest of the agents. This Manticore is written in Java and the front end, the dashboard, is written in HTML and CSS. So as you can see, we have three main types of the reports: the system report, capacity report, and the inventory report. System report itself has three more important parts to it. The first is overall stats, the second one is the XDR latencies, and the set statistics. System reports and capacity reports are more focused on the application-specific stats, and users can take any actions if required. Inventory report is mainly for Aerospike database administrators to show node status, build status, memory, and disk usage. So as you can see, this is an example of the system report which shows cluster comparisons as well. So you can see this is the main arrow 2 is the cluster group name and it has three clusters in it: cluster 1, cluster 2, cluster 3. So as Vincent mentioned, we have like different data centers. The first one is primary, second one is the local standby, and the third one is DR. So we want to really compare how the replication is occurring between the clusters and how they are performing. So for this view really helps us in getting all the information in one page. Now if we look at the overall stats, Manticore fetches total number of keys by querying every node in the cluster and adding up the value. Similarly, it calculates total memory, disk usage, along with total reads and writes happening per cluster. So if you see the read TPS and write TPS, it is not accumulation, but the maximum connection happening on a single node in a cluster. But rest of the values are aggregations. So system report also has XDR stats. To really find out from the client side how Aerospike DB is performing, we push like 100 plus records to the peer cluster. So when I CV, it's Manticore pushes the 100 plus records to the peer cluster and reads the timestamp for writing and reading, and that is called as latency. And that is what we show as XDR stat inside the report. So in Aerospike, it is not very straightforward to find out total storage taken by a set or total storage density. So for that, when users see that capacity for a cluster is reaching the maximum threshold set, then users need to know which set is taking or consuming more storage and to free up the space or to really move that set to another cluster. For these actions, one need to find out which set is consuming storage the most. In Manticore, we leverage histogram heavily for this task. Aerospike provides histogram information per set. This histogram, as many of you know, provides values along with the width or size of the bucket. Using that, we calculate the total used disk, present it in the report. Okay, so these was the slide and the next one. So as we seen before, the system report shows cluster group level information that users can leverage to monitor their system performance and to find out basic stats about the usage. From admin perspective, we would like to keep an eye if there is any issue happening at the node level. So any hotkey issue with one node in a cluster or any node is missed to be patched because say it was out for some time, the inventory report shows data for all the 2000 hosts we have in one view. It also shows list of all the nodes which are down in a cluster at the top of the email report. So this is the capacity report format. It is heavily consumed by our users to keep track of total free memory and free disk available per node. We have also color-coded the percentage for easy visualization and highlight with red ones which are about to reach the maximum threshold assigned. As I mentioned earlier, Manticore sends the data to the dashboard as well as to the Grafana dashboard. So why do we really need to have a dashboard? Is to see the historic view of all the metrics and statistics that has occurred in a cluster. So we have created this dashboard for a whole cluster group. So it also helps us to see the trend of the health of the clusters in a cluster group. And we are also saying these stats to the graph dashboard to really put alerting on top of these. This also helps us to quickly triage an ongoing issue and reduces the turnaround time. This is how Manticore helps us keep track of all the issues and changes happening across the nodes. With this, we will now move on to our question and answer section. So we also have this poll here that if you're interested in Manticore and if you like to really open source it, please feel free to answer the poll as well as give us your information in the Q&A section so that we can communicate or give you more information about it. Thank you.
Okay, great. Well, thank you. If I'll ask our other presenters to rejoin and reactivate their webcam, we'll start our Q&A session. Okay, great. So our first question, and again, I'll let anyone just jump in, is do you run Aerospike on bare metal? Do you run it on Kubernetes, on Mesos?
Okay, well, let me answer that question. We use Aerospike primarily for performance reasons. So therefore, we are running Aerospike on bare metal. In fact, we buy the best performing SSD for our clusters. So yeah, we don't use the Kubernetes or the VMs. However, we are actually exploring using GCP, Google Cloud, for various purposes, such as internal development purpose or QA purpose. We haven't decided whether we will use GCP.
Okay. Next question is, how do you validate changes in your management code?
A good question. Well, our management code is just like any other programs, right? Although it is a Ansible script. So our development of those codes are typical of that of a development cycle. So we have our QA environment, we have our test Aerospike installation. So we will run against our own QA environment and verify the Ansible script to be working before we use it. So yeah, we just go through the typical development cycle.
Okay. All right. I love pretty straightforward. Our next question is about playbook. What happens if one of the playbooks fail in runtime? If there's an external factor like a network outage.
Right, that's a very good question. We encounter that a lot of time. For example, on every playbook, the first step that we run is called validate cluster. The reason is we want to make sure all the nodes are running before we bring any down, right? So for example, when we have 20 nodes, we want to make sure there is no node is down, because if one node is down and then you bring up the second node, you are running into the risk of, failing some query because we only have 2 copies of data. So the first step is to validate the health of a cluster. Now, sometimes it fails, right, due to networking problem and all that. So for that matter, it requires manual intervention and manual attention. So typically, we will stop the run of the playbook, and we would make sure the down node is being brought back before we continue the automation steps. So yeah, that's a manual step.
TT, anything to add?
Yeah, I think Vincent covered it well. So we are validating everything first in our Q environment, and then we run the validation before we are running the scripts, and after that also, just to validate everything is working fine. Then only we proceed node after node. Got it.
So how do you, could you just go over again, like how you validate changes in the management code?
Okay. Well, by management code, we are talking about the Ansible script that we develop. So as I mentioned, we would validate by running it against our QA environment to make sure it works. For example, let's say we introduce a new variable or a new environment or new flavor. One typical good example is recently we are introducing a new memory technology by Intel, right? So for that, it actually have a different kind of configuration in terms of memory and how you partition the SSD. So that we would develop a new flavor, and then in our Ansible script, we would have to set that as our environment for the new cluster using the new technology. So therefore, we have to run through a typical setup using some hardware that we have purchased of the same skill. So basically, it is a full-blown test cycle.
Okay. So could someone comment? Thank you for that. Could someone comment, and maybe this is related to playbooks or not? It's unclear, but the question is very straightforward: is how do you load balance automatically? Or how do you load balance?
I interpret this load balance meaning the data rebalancing occurring between nodes of the same cluster, rather than load balancing the live traffic coming into our clusters, right? So between nodes, it actually is a feature of Aerospike that it would manage itself by automatically moving partitions among the nodes based on where the copy is on the master map. Right, so we typically don't need to do anything of that. The only thing we want to manage is to detect the completion of the load balancing, right? Because we want to, before we go to the second node and bring it down and install a new version of the software, we want to make sure the previous node, the data rebalancing is finished, right? Otherwise, you would be constantly in load balancing node by bringing one node down and one node up and one node down. So the only thing we care really is to detect whether the load balance has finished. So for that, we are using, we are based on some Unix scripts to detect that because it's outside of Aerospike environment. We are actually monitoring the log file.
Got it. Okay, I think this next question is for Deepti. Deepti, what was the biggest challenge or gotcha when developing your playbooks? What were the key lessons learned?
So the first one will be the how to keep our framework generic in nature. So it's easy to develop when we have just one environment. Now, if we have to make our framework generic in nature that can run well on cloud and again on bare metal machines equally, so we need to check the performance, how much time also each playbook is taking in connection and getting the facts, and what kind of errors we get while resolving it. So I think it was mainly related to the performance that we were looking at, that we wanted to do it quickly. So that was the biggest one, that we have to make modifications for the performances.
Gotcha. Okay. I think this next question is for Neha. Neha, is Manticore a vendor product or is it internally developed by PayPal?
It is internally developed by PayPal. So we have worked on it step by step, and phases is started with the system reports, and then we come up with inventory report and the capacity based on the needs of the users.
Got it. As a follow-up question, I noticed a lot of the reports, actually a couple questions, looked point in time. I assume there are certain trending reports that it also offers.
Can you repeat the question?
Oh, do you have, it looks like the reports were, I'll say point in time. Do you have trending overtime reports for visualization as well?
Yes, that's correct. So we actually send data from Manticore to the Grafana dashboard. So we can see trends there of the connections or if the nodes are up and down. And we can also see how much total memory and storage is used.
Got it. And as a follow-up, is it connected to alerting as well? Do you have certain parameters that you set?
Yes. So first it's if there are connections. In case of hotkey issue, it's what happens, only one node gets most of the connections. So those kind of things we have put alerts on so that we can easily take care of that hotkey issue as soon as we get an alert.
I see. Okay, very good. Look, I want to thank all of our presenters today. We've gone over time, but I think it was well worth it. So thank you to everyone that listened in. The session will go on demand within the hour, and again, people are more than welcome to submit follow-up questions in the Q&A box. We will route them to all the presenters here. And again, the session slides are generously available for download from the team. So again, thank you.
Thank you, Matt. Thank you for your coordination.
Thank you so much.
Okay, have a great rest of the session, everyone.
All right.
Okay, thank you.